this output voltage, this V out, this equal to 0. This will be the Kirchhoff's voltage law. So this we can represent this V is equal to this diode voltage VD plus your V out. So this diode voltage VD plus what is this B out? B out is nothing but the current I is flowing through this. So we can have this as the I into RL. So here let's say this current and voltage are just two variable. If you take this two as the two variable, then we can say that this relationship can be represented as this I is equal to this what will be the relationship? This will be V by RL minus VD by RL. So you just see this equation here. Let's say this I and if you want to study the characteristics or behavior of this circuit when we connect the diode with a resistor, then how this behavior will change. So here we see, as you can see, that this voltage and current, these two parameters as the variable. So what is this load resistance? This resistance will be a fixed quantity. Voltage across the diode is also a fixed quantity. It may be silicon diode, so it will be 0.7 volt or whatever the voltage. Okay. So this quantity will be a fixed quantity. So this is just in the form of y is equal to some it is I is equal to 1 by RL. This is a fixed quantity into V. So minus, or we can say this is plus y is equal to mx plus c. So this will be minus VD by RL. So is it an equation of the straight line? If you say this is a constant quantity, this is a constant quantity. So this y is equal to mx plus c. In this form we are getting a relationship or linear relationship we are getting. Okay, where slope of this will be your 1 by RL. So this represents a linear line. So this is called as the equation for your load line. Suppose for this equation if you plot the graph, so how can you plot the graph? If you graphically represent this, then how we will have this? So suppose this is the, just a minute. So suppose this is the voltage axis, this is your current axis, or x-axis or y-axis. So for representing this straight line, we at minimum we require 2 points. So how to get these 2 points? If you put 1 as the 0, that means 1 coordinate b is equal to 0. If you put b is equal to 0 in this equation, then what will be the value of your I? I will be how much?
Minus VD by RL.
Minus
VD.
Yeah, if you put
minus VD by RL.
Yes, VD by RL. If you put V is equal to 0 minus VD by RL we are getting. Or if you take this I is equal to 0.
So V equals to VD.
P equals to VD, diode voltage. Okay. So two fixed point we are getting. Okay. Two fixed point we are getting. So when we get to this two fixed point, so how we represent this? At V is equal to 0. V is equal to 0 means this current axis. Okay. This current axis. So this current axis, if you take the magnitude value, this BD by RL, somewhere the point will be here. This BD by RL point. Okay. BD by RL point. So this BD by R.
Ma'am, it's minus VD by RL.
Yeah, minus VD
Yes,
by
ma'am,
RL.
minus.
Just I have taken this as the magnitude value. Okay. So this will represent this direction of your current. So magnitude value just I have taken this VD by RL. If negative sign is there, then the current will flow in opposite direction. Only I have kept this magnitude value. Okay. So if I take I is equal to 0, that means this voltage axis. So where V is equal to VD, somewhere the point will be here. V is equal to, let's say, VD. So if we combine these 2 points, with a straight line, this will represent the equation of this. In this equation 1, the straight line is the graphical representation of this. So this is called as your load line. This line is called as your load line. What is this load line? That means whatever the value of your voltage will vary, but the change in your current and voltage will be, or the operating point will move in this line. What is this operating point? Means at this what a particular condition, suppose we take point here. So this point represents some value of your V, some value of your I. So this is called the operating point. That means at this voltage the current is this much. At this voltage the current is this much. So this relationship is a linear relationship. So this is represented by a load line. So usually we have the DC, we have the diode characteristics, only the behavior of the diode we know. So according to the diode characteristics, we have the graph like this. This is the VI characteristics of your diode.
Yes, ma'am.
VI characteristics. So if you plot the load line and VI characteristics, the cross section point is called as the Q point, or it is called as the quiescent point, or it is also called as your operating point. That means at this point the diode is operating in your circuit. So according to the position of the Q point also the signal behavior will change, that we will discuss when we discuss about the transistor. There, how if the Q point is moving, then how the operation of the circuit will change. So this position of this Q point is also an important factor when we go to the higher, that is about the transistor. Transistor is nothing but a combination of two PN junction. So this operating point is also a very important point in electronic circuit analysis. So this this is called as your DC load line. Here we have applied a DC voltage and we have taken the current, whatever it is flowing. So this is the DC voltage and DC current we are taking. So this load line is called as your DC load line. This is your DC load line. And here we have also considered the static characteristics of this graph also. This graph is the static characteristics of DC load line we have considered when we take the DC characteristics of the static characteristics. So when we apply a AC voltage, so this is about the DC load line. Okay, this is about the DC load line. If you apply a AC voltage, so there we will have the AC load line. So instead of taking the V volt, if you apply the circuit voltage or input voltage or alternating current, okay, alternating voltage if you applied, then this diode, this is the load resistance RL, okay. So this input voltage, this is a suppose this input voltage is AC. So AC means there must be some range of your voltage, like this will vary from this to this. So there are one will be a minimum, another will be a maximum value. So this B in value, usually B in is written means B in is usually represent the positive peak को represent करता है. So this B in voltage is AC form, in AC form. In this case we apply the same concept. So here we will get the load line. So let us plot the load line for this. So when we apply the current, this concept, this AC concept to your voltage versus your current graph, okay. So in this case what will we get? In this case, just like your previous equation, here only the voltage is not a fixed quantity, it will vary from some V in to some V in dash, let's say. Suppose the AC voltage which is varying from V in to V in dash. So one is your V in, another is your V in dash, and two range of voltage we are getting here. So obviously when the voltage is V in, we will have this just like your V is equal to VD is equal to V we are taking, here it will be V is equal to V in we have to consider. Likewise here we will get the minimum, the current point when we take this Vx is 0. In this case it will be your V in by RL. Similarly, when we have the voltage that is other peak, that is V in dash, In that case, it is V in dash will be your voltage. For this corresponding, we will have the current, that is V in dash by RL. So when we just join these 2 points, this will be coming in, sorry, just parallel line we are getting. So these 2 lines will be parallel to each other. Just consider this as the parallel line. Suppose this is your V in dash, this is your V in. So 2 load line we are getting. So these are the AC load line. For different values we are getting different load line, but they are parallel to each other. So if they are parallel to each other, what it indicates? And if you join the characteristics, that is the DC characteristics or static characteristics of, suppose this is the DC characteristics. Suppose this is the static characteristics or DC characteristics of the diode. So it is the cross section we are getting 2 operating point. Let's say this point is A, another point is your A dash. Okay. So for getting the dynamic characteristics, what we can do? So this, let us join this values like.
I'm sorry, ma'am, but can you please explain again how there are 2 lines?
Okay, I'm good. Just explaining. Okay, so when we considered about the AC voltage, okay, AC voltage means it's a alternating voltage. So it is having 2 values. Suppose this is your V in and suppose this is your V in dash. Okay, so this two for the 2 value, one for this peak we are having, actually this is the maximum voltage whatever it is applied, VM. So this value is your V is equal to V in. In this case we are getting this V is equal to VD, the diode voltage is maximum applied voltage B now. Okay, and for this case here the diode voltage is applied voltage B in. So for this particular voltage, when we consider this voltage, like the equation we are getting, that is your equation is your here V in minus this diode voltage VD minus your output voltage B naught, or we can say this is the I into this RL is equal to 0. In this equation, if you apply this voltage V is equal to applied voltage is your V in. Here applied voltage is your V in. So in this case, this V, when we consider I is equal to 0 for this axis, for getting this point, so this axis we are getting I is equal to 0 means V in is equal to VD. For I is equal to 0, V in VD is equal to V in. If we put in place of V in, this is the V in dash other voltage. So in that case, VD will be equal to your, for I is equal to 0, VD will be equal to V in dash. So 2 different points we are getting here. Okay, 2 different points we are getting.
Yes, ma'am.
So for 2 different points here, if you take for this condition, if you take this V is equal to 0, in this case your I will be equal to VD by what is this I? VD by RL, sorry, V in by RL, V in by RL. Applied voltage VD is equal to V in. So here the voltage will be V in by RL. In this case, it will be V in dash by RL. So just 2 points we are getting, instead of getting a fixed point, the variable point we are getting. So for variable point, we will have different load line. If you take, because the alternating voltage, suppose at this particular voltage you are calculating the load line. So at this point, this voltage may have a different value. So any other load line can also be obtained. So in case of your AC condition, or when we apply the AC voltage, in that case we are not getting a fixed load line. The load line is also vary, but the properties of the load line will be they are parallel to each other. They are parallel to each other. They are parallel to each other means what information it is giving in parallel condition? If they are parallel, what it is information is?
Learning also.
What information it is?
Image processing today we are going beyond the 2-dimensional and going deeper to see
The resistance are same.
The resistance 1 by RL is same. That is the slope of the graph is same.
Ma'am, you are muted.
Ma'am, you are not audible.
along with the
Yes, yes. Sorry. So for that, this RL is constant. So if RL is constant, the slope is constant. Okay.
So we should be
So slope is constant. So if your slope is constant, we will get obviously the parallel line.
in a foreign country.
And if your slope is constant for static load line, if you join this load or this Q point and this voltage point, and this point the
Ma'am, you are muted.
On the highway, you lose your way and
No, I
don't
have not
understand
muted.
the street signs.
No,
Many
I'm
tourist
on.
and business travelers find
Ma'am,
themselves in similar situations all the
I
time.
wanted to ask, like you have said that V in and V in dash are the two peak voltages. So either V in dash should be the in the opposite direction of the magnitude. It should be like on V in.
Typing this, simply
Please repeat.
do a search by image.
Ma'am, you said that V in and V in dash are the two peak voltages. So either V in dash should be in the opposite opposite
So this is
direction, or V in dash should be on the point V.
Yeah, actually, when we take the voltage for the theoretical concept, whatever we take, actually in theoretically we just represent this AC voltage as the positive or negative, that kind of things you are saying. That's
Yes, ma'am.
yeah, that is the thing. But actually, when we take the, sometimes suppose we take the values like this. This can also be a this is also can be a AC voltage, alternating voltage. So it will have two values. So to show this, only we have given two different values. Okay,
And
it can
V in
be.
dash is any general point on that sinusoidal curve.
Yeah. We index can any point here. So this load line can number more than two also. Just to show that this is variable voltage is there, we can have different load line, but they will have the fixed slope. Okay, fixed slope means they will have the fixed resistance, the slope will be constant. And if you join these points, like from this origin to this B dash point, this will actually this is also this kind of graph we will get. This is called the dynamic characteristics. This is
that there is some obstacle at the right hand side. So
Ma'am,
once
what is the
this type of application are developed,
yes.
Ma'am, your voice has been cut off by some background noise, I guess.
some millions of
Okay,
lives,
just
giving them independence, giving them dignity who are
hold
disabled
on
actually.
1 minute. Dynamic characteristics. Is it audible properly now?
Yes, ma'am.
Yes, ma'am.
Yes, ma'am.
So in dynamic characteristics, we can have from the AC load line. If you get the operating point, here also the operating points will be varying from point to point as the voltage is changing, the load line is changing. So the operating point is also not a fixed point here. It is changed according to the change in your voltage. So from this operating point and with respect to this voltage, if you join the point and connect this line, this is also an exponential line with a different slope we are getting. This is the dynamic characteristics of this diode. So how when the AC voltage is applied, how the behavior of the diode is changed, that is represented by the dynamic characteristics. So this dynamic characteristics has also very important role because usually we have this uh, application of diode whenever we are using in the input, instead of DC signal you usually use the AC signal. So generally we use AC signal, like if it is a rectifier circuit. So obviously we are giving AC signal for converting it into the DC form. So in the input we are applying the AC signal. If the diode is used for the purpose of a wave shaping circuit, like suppose some portion of your some different wave shaping applications are there, like clipper or clamper circuit. Suppose you want to change, suppose this is the waveform and we want to change the waveform to this kind of waveform. Okay, so for some application, suppose you want to clip off some portion of the waveform, or sometime you want to change the diode this signal to a different DC level. Okay, so in this case we can, all cases we are using the AC AC signal. So this AC load line and AC characteristics or dynamic characteristics, it has more importance in this VI characteristics or this load line analysis. So we should have this load line analysis in a proper way. And one more characteristics, it is not mentioned in your syllabus, but it is there in higher semester, that is called the transfer characteristics also. Transfer.
So basically, I would like to discuss how can we process this huge amount of text data.
Transfer characteristics, actually it is the characteristics of your input voltage by your output voltage. Input voltage versus your output voltage. The curve which relates the input voltage and output voltage is described by the transfer characteristics. So it is not required for you people for the higher semester of BECE student, it is required for transfer characteristics. So from the transfer characteristics, from graphical analysis, we can also have, if you have the input voltage, we can get the input waveform, then output waveform can also be considered. So if possible, then when we use the rectifier circuit, obviously in that case we are concerned about the input voltage signal as well as output voltage signal. So this input and output will be related through this transfer characteristics. So analytical method we can apply for finding the output voltage. Also we can use the graphical method or the transfer characteristics method for finding the output waveform from the input waveform. Whatever the input signal we are applying, what output we will get, that we can analyze from the transfer characteristics. So we will use this transfer characteristics for in the analysis of your rectifier, we can study this transfer characteristics. Okay, so this is about the AC load line and DC load line of this diode. Then one more thing is that is your about the capacitance. I think I have given that slide. In the slide it is there, the capacitance part is included in that slide, so you can follow that. Okay, So in case of your diode, what the capacitance, where the capacitance come across here. So actually capacitors, what is the function of capacitor is known to all of you. So this capacitor will store the electric charge in the form of your electric field. Okay, so that is the basic concept of your capacitor. So this in case of your diode, how this capacitor is not physically present there, but the capacitive effect is there. So how this effect can be studied, like when we applied, actually you just go through this concept, actually one meeting is already started. So we'll have this capacitor discussion, you just go through the slide, okay? We will discuss it in the next class. So actually I have to leave this because one urgent meeting is going on, so I have to join. So this transition capacitance, diffusion capacitance, and load line already we have discussed. So after completing this, we will switch over towards the rectifier. So in the next class, I think Thursday morning, we will discuss this capacitance part little bit. After that, we will switch over towards the application part. So let me end this meeting.
Ma'am, please share the slides which you had drawn.
Yeah, this slide already I have shared. So the Word
No,
file.
ma'am, the one which you have drawn today.
Yeah. Word file I will submitting. Just wait 1 minute.
Take the attendance.
हाँ attendance ले लेंगे.
So obviously, suppose there is a resource there, and if there is large collection of stuff, and then find the individual paper, so there is a time possible. So rather than it can be somehow, develop the individual experience, which can help in accelerated research. So we can prove papers based on their topic, on different clusters, and then suppose the
Can anybody download the attendance? Actually, I am having certain problem. It is hanged. Is it possible from your side to download the attendance?
No, ma'am.
No, ma'am.
Maybe if you can make one presenter.
Yeah. Actually, this system is not responding now.
topics of COVID. I know it's very what is the topic of the article. In this particular work, we try to segregate the articles into different categories.